Hi, I'm Kurt Mumel. I'm Dataiku's head of AI strategy, and I have the great pleasure of speaking with you today at Product Days about an architecture paradigm for building lots and lots of LLM-powered applications in the enterprise. Now, we talk about this as being the LLM mesh, but before we get into all of that, yeah, I think it would actually be very useful for all of us just to break down what I mean by an LLM powered application. Because, of course, we're all familiar with some of the, let's say, uh, traditional, basic, original, first generation application types that use LLMs. The first, most famous, perhaps most obvious, most common is going to be a chatbot, right? That's ChatGPT. That's that format, right, where you have a chat interface, a window with a text box, and you send a message. It goes and gets sent to an LLM as a prompt. Usually, the application is appending some sort of system prompt to that as well. But then you, as a user, you receive back an answer from that LLM, and it feels almost like you're chatting with a human being. That's what made these applications seem so remarkable, right? Really gave us all the impression of their great intelligence. And then, of course, in the enterprise, especially, we've been speaking a lot about RAG, right? Retrieval augmented generation. So this, takes kind of a similar format, chatbot interface, but then adds on to it the ability to look up information in documents, and then I'm sure that you're going to see within some of the presentations here at Product Days, Dataiku's Answers application. And this, of course, is also a chatbot application type. Dataiku Answers, like others out there, also now has the ability to look up data from a database. And what it's doing is it's translating the natural language question that the user asks of it. The LLM is translating that into a SQL query, which then goes to the database, returns an answer. That goes back to the LLM. The LLM takes and formats that as text and then responds back to the user. So, of course, this is a very standard application type. But in the future, already in prototype, but in the future, at scale and in production, will be other types of applications, more sophisticated applications, applications that take advantage of the LLM's ability to propose a solution to a problem, to break down a problem into several steps, and maybe even use tools and so on to solve that. And with that, we've begun, we as a kind of collective, the people who are working on this, everybody, perhaps yourself, we're starting to use the term agent to describe that. And of course, there's, as always, a lot of debate about the exact definition of an agent. But basically, the way that we're going to be using it today is as an application that has a specific objective, which is able to accomplish or go through several steps in the process of solving that task for the benefit of the user. So rather than speaking about this, let me break this down. And so to start with, let's look inside of what an LLM powered application. What are those different components going to be? And as with a lot of applications, right, we're going to have different layers that we can think about within this application. At the bottom is a data layer. Above that is a services layer on top of that data. Above that still is a logic layer explaining how you want to use those services. And then at the very top is the application layer, which is where that end result actually gets exposed to the user. That's the user interface, and probably other functionality around that. And as you can see up in the key in the top right, we have some LLM specific objects within this architecture, but we also have some traditional objects within this architecture, which is to say, objects that we've been using to build enterprise applications for years and years. And so it's perhaps no surprise that we're going to start with our data, both unstructured data, often documents, text data, as well as structured data. But also down at that data layer, I'm going to put the LLM. Okay, so you see that's in green, that LLM specific color. But why am I putting the LLM down there? Well, in the end, right, the model itself is just a big flat file with a lot of floating point numbers. When we talk about the parameters of an LLM, right, remember that each one of those parameters is just a number, a number in a big file. Sometimes a really big file for the really big models, right? And everyone's getting excited about how big these models are getting. If we take some recent ones, one that comes to mind, I think it was Llama 3.1, one of the bigger versions, with several hundred billion parameters. That file is going to weigh, what is it? Comes in at like 2 point something terabytes, right? So it's a lot of data to manage. So that's actually one of the reasons we need to consider that these models, in effect, are kind of data that we need to manage. But to make them useful, of course, we need to expose them as services, right? And so that's all of the software and hardware, GPUs famously, that are needed to serve up that LLM for use, for inference, usually, right? Which is when that LLM is going to do its job. It's going to complete a prompt, and is going to essentially do what it's been instructed to do, which again might be think about how to solve this problem. But if we stay at that services layer, we can add on top of that retrieval services on top of that unstructured data. I mentioned RAG earlier, retrieval augmented generation. These are going to be services that use those techniques, right? Which are going to go and look up in some data store, a vector database or others, which is going to find some similarity between different vectors, meaning different text which has been embedded as vectors, to find an answer, to find text which is similar to the text in the question, and therefore is a likely answer to that question. It's actually can be more complicated than that, but just let's consider these services where you input a question and it responds with an answer or text which is likely to answer that question. Structured data, well, this one's easy, right? These are data querying services, fancy terminology for a database, right? Your SQL database. You query the data and you get a response back. Finally, at the services layer, I'm going to add a very broad category, API services, right? And that can be anything and everything that's going to expose an API. It can be external services, look up the price of a stock today or historically, or what's the weather forecast for tomorrow. But of course, it's also all of the internal API services as well, all of the enterprise systems, your ERP, your CRM, all of the acronyms, right? All of the software that has an acronym, which then gets exposed by yet another acronym and API. Okay, let's move up a little here. The interesting thing now for an LLM specific application is that those two last services, data querying services and API services, are going to be considered tools for this LLM powered application, right? That are going to be used or can be used to solve for the task that has been given to it. Finally, at that logic layer as well, we're going to have prompts. Prompts, of course, we're familiar with them. I presume most people watching here have used ChatGPT or similar chatbots, and so you're familiar with the notion of prompting. You probably have different notions of prompt engineering, but basically, these prompts are, in a sense, kind of the new code assets, right? It's where you're defining the instructions. It's where you're defining what you want that model to do, which means that as an enterprise is building out these applications, those prompts become an asset. They're going to need to be modular, shared, validated, tested, refined, updated, managed like a code base almost. Okay, we're missing something here though. These arrows aren't coming together anymore yet. So let's bring those arrows together. And where do those arrows all come together? Well, they come together in agents. So agents, that is the object within this diagram that brings together the logic of solving for a given problem using the tools available to it, using an LLM, being served up as an LLM service as a way to define its tasks, to solve the problem, to generate the code, to call the APIs, to look up the text, to then solve that problem for the end user, who then themselves is accessing it through the application, the interface, and the ancillary services that might be on top of that for authentication, whatever it may be, right? So ultimately, right, these are the objects which go into building LLM powered applications in the organization. And this is a simplified schematic. This is not actually how any one application works. These are simply how the different types of objects that go into these applications connect in general with one another. Right, because a real application might have different loops in here, and the agent is going to go and use multiple or different LLM services to solve different parts of the problem. It's going to use multiple or different tools, and so on and so forth. Right. So This is new. This is exciting. It brings new opportunities for automation, for augmenting the intelligence of all of our different capabilities within the organization. So these are great, right? But the question is, how many such applications will an enterprise actually need? I think that I remember very early on in this, kind of generative AI in the enterprise adventure. So shortly after the release of ChatGPT, there was an initial wave of enthusiasm that really thought that this is great. We're going to be able to have one single chatbot that's going to answer any question about the enterprise. And, we've basically solved all predictive analytics, all, internal data querying needs for good. Now, we don't actually think that's the case, right? It's not going to be one big, massive, oracular, all-knowing, all-powerful application. But the question remains, right? How many is it? Is it tens? Is it hundreds? Is it thousands? More than thousands, right? Tens of thousands? What is it going to be for a large organization? When I say large organization, imagine, tens of thousands to hundreds of thousands of employees, kind of, some of the biggest companies out there. What would it be at that scale? Well, let's think about what the actual need would be. So here, let's take an example, which could be an imaginary pharmaceutical company, right? And I just chose an industry just so we can have the right departments show up here on my little diagram. So across that organization, you have different departments. There's 5 different departments here. Those are the columns, right? Sales and marketing, finance, operations, research, and HR. Of course, there's others as well, but we're just doing an order of magnitude estimation here. And within each one of those departments, you have different functions. What we anticipate, right, is that there is a need to automate decision making throughout that enterprise to augment the abilities of each and every one of these functions. And that within one of those functions, so each one of those smaller rectangles, you're likely going to have the opportunity to benefit from a team of agents. So within that sales performance team, you could have a team of agents doing different specific things. An account expert, which is going and doing research on the account and providing that to the account team. MedPick, that's a sales methodology, which is maybe enforcing that, checking to see that the required documentation is in the CRM the way that it needs to be, and so on and so forth, right? And so, why would it need to be broken up in this way? Why can't we just have one big LLM-powered application to cover all of these? Can't these agents, handle different situations? And isn't that what they're, good at? What isn't that what's special about them? Yes, but and the but is because to define these properly, to get consistent results, they actually have to be scoped pretty narrowly. You have to give pretty precise instructions to the LLM on what it should do, on the way that it should solve a problem, such that you can get reliable, consistent results in the way that an enterprise would need it. When we're using generative AI, a chatbot, or an image generator for fun, for our personal life, we can tolerate, silliness and wackiness and, weird responses from time to time. But of course, in the enterprise, we need this to be consistent, reliable, and trustworthy, which means that each one of these applications will need to be relatively narrowly focused. There is also the consideration of data, right? And data access. Not everybody in the organization should have access to all the data. In fact, quite the opposite. Any one person should only have access to the data that they need to do their job. The same is true for the agents, for these AI agents. They need to be scoped narrowly enough that we can provide them with access only to the data that they need for a particular task. This is going to be important to ensure security, privacy, data controls, and satisfying all the different compliance requirements that enterprises operate under, right? So let's do some back of the envelope math. We had 5 different departments. And count the little whitish rectangles in each of those columns. There's 5 each, and then within each one of those, we imagined 5 different agents. Do some multiplication, 5 times 5 times 5. We come up with 125 agents that need to be developed or purchased within the organization. And so that then brings us to the question of build versus buy, right? If we need to acquire or obtain one way or another 100, 200, 300 different agents for the business, what should we do? Because you better believe, right, that there's going to be a lot of new startups coming out of the woodwork, AI startups that are going to propose for pharmaceutical companies, a cost forecasting agent, which does just that. And it's going to work great. But should a good enterprise strategy be to simply buy these right off the shelf, or should you actually go and build some? Well, it's probably going to be a bit of both, as always, right? And the difference is you're going to want to buy those where you are looking for just an efficiency gain. But in areas where you need to have some sort of strategic differentiation, you're probably going to want to build it so you can do better than your competition. So that means that for some of these functions, and just pick some at random here to highlight them, you're going to want to go and build these capabilities yourself, meaning that organizations that want to get ahead with Gen AI are going to need to build a certain number of agents, tens to hundreds of agents that they're then going to need to maintain, to monitor, to update over time. And so let's think about architecture paradigms, because if we're going to need to build a lot of applications, we need to think about how we're going to do it, right? So let's compare this LLM powered applications with traditional applications. 20, 30, 40 years ago, the architecture paradigm for developing enterprise applications was monolithic applications. This is where there's one big code block where all the functions are defined, everything from data access to data querying to analytics to the computation of the different statistics to the visualization is all in one big monolithic code base, right? And this worked, right? These applications, they function. However, they're kind of unwieldy to maintain as you start scaling, building more of them, it starts to become a real headache, which is what led to the development of services-oriented architectures in the enterprise. This took and broke up the architecture of these different applications into smaller, separate pieces that are each managed independently, which are then brought together in a modular way. And that, in fact, services oriented architecture has ultimately evolved into what we have today as kind of the standard for new applications to be developed, which are microservices, which just follows that trend of breaking things up, thinking about them as not just one big application, but as a bunch of services that we can use to accomplish some task, which are managed separately, independently of one another. And ultimately, right, that's what we anticipate is going to be necessary for LLM powered applications. But today, right, the state of the art is monolithic applications. And look, it works, right? For the more advanced agents that I've seen, typically what you do is you start with a LangChain, you Google some code, or yes, ChatGPT to generate some code. You chain some things together, and look, you've had a successful POC. It works. That's great. However, this is ultimately not sustainable. And this is not sustainable typically, or most importantly, at scale. Because very quickly, right, once you start developing these type of applications, I've gone back to this diagram now. Imagine that you build an application like this, and it works really well within your enterprise, and you're very happy about that. But imagine, though, that you've gone and you've built this and it's successful, but people start hearing about it within your organization and they want to build their own or they want you to build one for them. And so you start going about it. It's all very exciting. But as you start building these new agents, these new applications, sharing different modules among one another, you end up with a bunch of spaghetti code, which is difficult to maintain, which is difficult to govern, right? Imagine if you wanted to do a cost analysis about how you're using the different models across this entire landscape. How would you go about it? Imagine that you just have to go and maintain this, or imagine that you want to migrate from one model provider to another. You have to update this throughout the entire plate of spaghetti that you have there, right? And now some of you might be thinking, right? Well, but Kurt, you're cheating here. You purposely made this a little bit messy looking, right? And it's true. I used curved connectors that kind of overlap one another to give the effect of spaghetti. Um, but what you have to keep in mind is that every organization has its limits, right? Some organizations are really good at managing a lot of complex codes, others less so. But no matter which organization you are, you have your limits, right? And we know that the number of LLM powered applications that as you have more of them, the complexity is going to go up. Probably, following some sort of exponential function, because adding one more application probably means more than just plus one in terms of maintenance, because you have to manage those interconnections, those dependencies among all of the different applications as well. And so any organization is going to have some complexity threshold at its starting point. And that's going to define the number of LLM applications that it can have, that it can maintain, that it can build, right? And remember, these applications, the ones that you build, are the most important ones. They're the ones that are giving you differentiation, that are allowing you to outcompete your competitors in some important, even if it's a small, but some small but important way, or maybe a big and important way. So the question is, how can you raise your complexity threshold, which takes us and moves us from that little tick mark on the horizontal axis, moves us farther to the right. That's where we're intersecting up there now, and we can now have more applications resulting in more value. Well, I led in with this, right? The answer from Dataiku is going to be the LLM mesh. It's a simplified and standardized architecture for building LLM-powered applications in the enterprise. There's three principles, right? Uh, the first principle of an LLM mesh is to create an abstraction layer through which you're going to access all of the different services, the LLM services, but also the retrieval services, the tools, everything, right? We need an abstraction layer. You shouldn't be building the connection into the logic of the application itself. Two, you need federated, shared services for control and analysis because each and every one of these applications is going to have very similar needs in terms of cost control, cost monitoring, in terms of security, permissioning, in terms of content, in terms of like toxicity detection, and so on. And then three, we need to have centralized discovery and documentation via a catalog, not only for the people, the human beings who are going to be building these applications, yes, for them for sure, but actually also for these systems themselves so that they can understand what is available to them or what has been made available to them so that the agents can use the other agents or can use the other tools available to them. And that's ultimately where we see things developing. And if we use an LLM mesh, right? And I want to be clear, right? LLM mesh is an architecture. Dataiku, we have our own offer, but it could be built outside of Dataiku as well, using whatever tools you want, right? But ultimately, what it should end up looking like is something like this, where you start with your catalog, where you have all of your different services, all of your different components, all of your different objects that you're going to want to build with. You have all of your different services for control and analysis that you need to use to make sure that your applications are working well. And with that, you can start building these applications in a more sophisticated, modular, composable way, in a way that you can reuse different assets so that they can become stronger, more capable together, while you are very much able to monitor what your cost is, what the performance is, which LLM services you're using, where you can migrate from one in another, right? And this, of course, it's a more advanced architecture. You don't need it to build one single application, though it would be helpful for that. But you certainly need it when you're building tens, dozens, hundreds, say nothing of thousands of these applications at scale. Now, most organizations are not there today, but we think they're going to be getting there very, very quickly. If we've learned anything about how this is being adopted in the enterprise, is it's going kind of quick. And so this is one of the reasons that Dataiku is thinking about this so much. We're thinking about this so much, in fact, we're writing a book about it. So we're writing a technical guide with O'Reilly called The LLM Mesh, a practical guide to using generative AI in the enterprise. Chapter one is already available with that QR code or just with a quick Google. The full book is going to be available in Q1. The second chapter will be available, let's say, early to mid October, and more chapters will be coming out between now and the full release, because we believe that this is actually a really important architecture for enterprises beyond, of course, what Dataiku is offering specifically. Now, not only are we thinking about the architecture, of course, we're thinking about the product as well. And you'll hear lots more about what's available in our product. But just know that the LLM Mesh is part of Dataiku's generative AI capabilities as part of the universal AI platform that we offer, right? And it includes the basic, kind of core layer of the LLM Mesh. So that's that catalog, that gateway that we provide. There's then the tools for building. There's the guard services. That's the Dataiku branded version of the federated services that I mentioned previously. And then ultimately, all of this is within the governance package that Dataiku offers. So thank you very much for your attention. I hope that this was interesting to you. And I hope that you enjoy all of the rest of all of the different sessions that you will have here at Dataiku Product Days. Thank you very much.